So far in this chapter, we've seen several graphs of exponential functions, and we learned they always form a curve. In addition, you may have noticed all the graphs have a really flat part at the bottom or top of the curve. This flat part is related to a feature of exponential functions called an asymptote. An asymptote is a line that the graph approaches but never actually touches or crosses. It represents a boundary the function gets closer to but never reaches. For example, in the function y equals 2 to the x power, the asymptote is represented by the line y equals 0 because the graph gets close to 0 but never actually reaches it. Let's see why this is true by looking at a table for this function. If we start plugging in numbers for x, like the numbers 0 through 5, we get the coordinate pairs 0, 1, 1, 2, 2, 4, 3, 8, and so on. The y values keep multiplying by 2. However, if we go backwards from 0 into negative x values, we start getting fractions / decimals. So, negative 1 for x gives us 1/2 for y, negative 2 gives us 1/4, negative 3 gives us 1/8, and so on. As we start to plot these points on the graph, notice how they keep getting lower on the y-axis close to 0. However, since we're dividing by 2, we're never actually going to get to 0. The numbers will keep getting smaller, but there will always be a smaller and smaller decimal number. Dividing by 2 doesn't actually reach 0, it just gets really close. This is what an asymptote represents. In every exponential function, this scenario exists. We get closer to a number, but we never actually reach it. Therefore, if we go back to the graphs we displayed at the beginning, we can label the asymptotes with horizontal lines and their equations. Notice how 3 of the 4 flatten out at 0, so the asymptote is a line labeled y equals 0. Then the fourth graph flattens out at negative 2, so the asymptote is a line labeled y equals negative 2. Overall, in Algebra 1, we only work with horizontal asymptotes like these, so the equations of the asymptotes always start with y equals. Finally, we can also figure out the asymptotes of exponential functions by looking at their equations. Let's start with the 4 graphs we just looked at, beginning with the final graph, y equals 4 times 2 to the x power minus 2. The asymptote for this graph is the line represented by the equation y equals negative 2. Can you see where this shows up in the equation? That's right, at the very end of the equation. If we look at the first 3 graphs now, we know their asymptotes were all y equals 0. This is true because none of the equations have a number at the end like the minus 2 in the fourth equation. Since there's no number, that's the same thing as writing plus 0 at the end. And again, the asymptote is y equals 0, so that matches. With this in mind, here are 4 more equations. Pause the video and see if you can figure out what the equations of the asymptotes are. Again, the number at the end of the equation represents the asymptote, so y equals 6, y equals negative 4, y equals negative 11, and y equals 0 are the asymptotes here. And here are the graphs to prove it.